Hello everyone, I'm Dr. Lifang Zhou from Chongqing K-Laboratory of Image Connection, Chongqing University of Posts and Telecommunication. The topic of my report is IoU-Guided Siamese Region Proposal Network for Real-Time Visual Tracking. The presentation will be developed by the following 6 fields. Object tracking is the most fundamental problem in computer vision that aims of estimate of the states of a specified object in a continuous time series of images. For example, the tracking object is given in the first frame, and the position of the object is predicted in the subsequent frames, like the picture shows. Object tracking has broader application prospects and communication view. It has been widely used in intelligent video surveillance, modern military, intelligent visual navigation, and so on. In the field of tiger tracking, common challenges are deformation, illumination values, out-of-plane rotation, in-plane rotation, and so on. Those problems have been improved to a greater or lesser extent in past studies, but object tracking is still a very challenging task because of the influence of many factors. And we find that there are still 2 issues that have not been addressed in the current work. First, the low correlation between the classification score and the localization accuracy. Then, the branch localization of regulations is not accurate enough. As shown in the figure, the red box have the highest score and the yellow box have the second highest score. Since the correlation between classification score and the localization accuracy is low, it appears that the yellow prediction box is nonetheless more accurate than the red prediction box in terms of localization. The problem is particularly marked in this picture. You can say this. In addition, since RPN treated the regulation branch with the same tiger tracking task, only one firm with the highest accuracy is needed to localization the tiger. If many anchor firms contribute equally to the regulation laws, will impair the tiger localization accuracy. In order to solve those 2 problems, we proposed an IoU-guided Siamese tracker that achieves higher tracking accuracy at a considerable real-time speed. Furthermore, we designed an IoU predictor to predict the IoU of each regressed anchor. During the testing, perhaps the score used for the final box selection is computed by multiplying the IoU score with the corresponding predicted classification score. Thus, the classification score and the localization accuracy can be easily associated. In addition, the object tracking task aims to obtain a candidate box with the highest IoU in each firm. We argue that for the regressed anchor, the highest the IoU is with the grand choose box, the more attention should be given. Therefore, an IoU-based weight factor is decided to regulate the contributions of different anchor box to the regulation lost. This is an overview of our framework. The first of them is of the image fed into the filter extraction network to extract the filter of the tiger, and then the output filter map is used as a template. The image of subsequent firms will also be fed into the same network to obtain the filter map of the search region. The proposed IoU predictor is paired to the regulation head to predict the IoU function between the anchor firm and the tiger for all positive samples. The IoU predictor uses the feature of the deep intercorrelation layers as input and consists of only two one-by-one convolution layers. The IoU prediction results are passed through a single-mode function to ensure that the predicted IoU is in the range of 0 to 1. It is worth noting that although there have been many methods to generate IoU labels, for example, by commuting the IoU between a defined anchor firm and the real firm correlation to the tiger. However, the predefined IoU may not be the best choice, because the regulation bunch have different regulation capabilities for each anchor firm. That is, the IoU of an anchor firm and the real firm of the tiger might not be the same before and after the regulation. Thus, in our work, the labels of IoU predictors are given by the anchor box after regulation and the real box of the tiger. Then we compute the similarity match between the future map of the first firm and the future map of the search region before finally performing the classification and the regulation tasks. The red box in our IoU prediction model, the IoU prediction score reflects the localization accuracy of a tiger, and the classification score reflects the score of that tiger. The product of the reduced IoU score and the classification score is used as the best for selection the final box. In this way, firms with high classification score but low IoU score will be surpassed. A simple IoU predictor will effectively enhance the correlation between classification score and localization accuracy. Those firms show how our tracker generates a tracking loss function so that the trade tracker model will focus more on the anchor firms with high IoU to the tiger. The W denotes the weight of each regulation firms. LC denotes the classification loss function. LR denotes regulation loss function. LI denotes the cross-entry loss function, and our total loss is shown in L. To validate the impact of the different components, we conduct evolution experiments on VOT 2016. The table presents the results of our approach using IoU Predict and IoU-Guided invisibly. Notably, the two components work together to produce an excellent tracking performance. What is of view is that when both models are add to the tracker. Overall performance improvements by 3%. We compared our tracker with nine. We compare our trackers with 9 trackers in VOT 2016. The results are presented in Table 2. As shown in Table 2, our Sims IG achieves 0.423 EAO score and 0.629 accuracy and 0.210 robustness score and outperforms almost other trackers. Specifically, CRPN in this one tracker used Castle RPNS and multi-leaf features, which makes localization more accurate. However, the low correlation between the classification score and the localization accuracy degrade the performance of CRPN. Sims IG outperforms CRPN by 3.5% in accuracy and 6% in EAO score. Although EAO achieves the best robust by updating the model, it can only run at a low FPS. The Table 3 is the results on VOT 2019. It can be seen the muscle posted in this paper achieves better results, both in terms of accuracy and EAO score. Those results fully demonstrate the effectiveness of our proposed method. This is qualitative results comparing Sims IG with other trackers on 3 hard sequence. As this picture, we can say our Sims IG can still track the tiger accurately when all other trackers fail to track. Here is our summary of this paper. First, we proposed an end-to-end trade IoU-guided Sims RPN tracker for visual tracking. Second, the Sims IG solved the problem of low correlation between the classification score and the localization accuracy by adding the simple IOU predictor. Finally, we upweight positive samples with a high IOU improve the tracking accuracy. This is our entire work. If you have any questions, you can send us an email to communication. And if you are interested in our labor, please contact me. Our labor mainly conduct researches in 5 directions: image processing, image filter extraction and application, multimodal data intelligence analysis, imaging connection and big data service, and multimedia security. So welcome cooperation. Thanks.